Okay, so we just got done talking about distal stimuli and proximal stimuli and how what we perceive in our environment is not necessarily exactly the information that we're getting onto our retina. Why does this happen? It's because we are actively organizing all of our incoming sensory information. Okay, so context really matters. Remember when we looked at the dress, right? The infamous dress. Some people see white and gold, some people see blue and black, and that's because of how you are interpreting the environmental cues about how you're interpreting your environmental cues, right? The environmental stimuli. So, here is an auditory demonstration, okay? One of the few auditory illusions that I can really effectively demonstrate here for you. These are called Shepherd scales, okay, or this is called a Shepherd scale. Okay, now. Okay, before it stops, I'm going to replay this exact same video over and over. Okay, it's the exact same video, and I want you to notice what tone this video started on. Okay, and when I replay the video, I want you to notice what tone it starts on when I replay it. What you should hear is the scale will just continue to keep going up and up and up, despite the fact that I'm replaying the same audio clip. Okay? We'll do it one more time. Okay. So, honestly, I can't tell you how to reset this. I'm not really sure how long you have to go before it, starts to go back to its original tone. But you noticed before that I stopped the video and talked a little bit and then started the video again, and it probably picked up right where it left off, as it probably will now. Okay, so it's still a lot higher than it was when you first heard it, right? Okay, so that is a Shepherd scale, and it works going the other way as well. Whoa. Ow. Okay, so there we go. If you interrupt it in the middle of the scale, then it doesn't work anymore. Okay, so there we go. That's a good way to get this to start over. We just made a discovery together, you guys. Okay, so pretty cool illusion. And what's happening is, again, active organization of everything that's going on. Okay, so you're not hearing just one note when you're hearing the Shepherd scale. Okay, you're hearing multiple levels of notes. Okay, so you're hearing this note, you're hearing the octave above that, and the octave above that. Okay, and then you're hearing the next note and the octave above that and the octave above that. Now, when you hear, let's say, this particular scale, and then you restart the video, perceptually, you're doing this. Okay, does that sort of make sense? Is that you just kind of pick up where you left off on that scale. And it's just the way that we seemingly organize auditory information. And because of that, we don't get a perception that matches the distal stimulus, right? That's again an example of the proximal stimulus, what we're actually hearing, the actual sound waves coming into the ear are not what we're perceiving, what we think that we're hearing. Okay, so let's try another demonstration. Oh, right, it's like an impossible staircase, the never-ending staircase. This is the visual representation, indeed, of the Shepherd's scale, right? All right. Now I want you to try this demo. I want you to take your finger, you don't have to touch your screen, okay? Just point at the object in this 3-object set that looks different from the other 2. Okay, so presumably everybody is pointing at the X, right? Okay, I'm going to move things. Still pointing at the X. Your finger didn't move, right? Finger didn't change at all. Okay, still pointing at the X. The X is still the thing that looks different to you. Good. Now, one more time, just to make sure you're really good at it. Now we're going to try it again, a different set of objects. You're going to point at the object that looks different from the other 2 when they come up, okay? And then I'm going to do the same kind of motion again, and we'll see what happens. Okay, so now point at the object that looks different. I'm going to move things. Are you still pointing at the object that looks different? If not, move your finger to the object that looks different now. I'm going to move it again. Okay, now you have to move your finger to find the object that looks different. And again, most of you are probably moving your finger back and forth, right? And you're probably wondering what the hell's going on, because these are the same 3 objects and she's just been moving one of them from this side to this side. So why is it that the one that's different is changing? What is the deal here? Well, in fact, the road on the far right actually is identical to the road on the far left, and the road in the middle is the one that is different from the other 2, right? Mind blown. Okay. So what's going on here is active organization, and what you're doing is assuming you're using your 3-dimensional skills, your 3-dimensional interpretation skills, right? We see the world in 3 dimensions. That's how we were meant to see it. That's how our world exists. Right, so that's how we are most likely to interpret it. So you see these 3 roads, and what you do is you think of 2 roads in the real world, and you think of a common vanishing point, right? And common vanishing point, when you look at those 2 roads, has to do with something like this, right? You see 2 roads in the real world, or this is one road with 2 halves of the same road. They sort of converge in the distance as a common vanishing point, so we know most likely that these are parallel roads, that they're the same size, or headed in the same direction, right? Those are all things that we can deduce from the 3-dimensional qualities of our environment. And these are all things that we tend to apply to most of our visual input. So we apply it to 2-dimensional scenarios, and it can get us into trouble, right? So we take this 3-dimensional interpretation, right? We take the distal stimulus, we translate it into what's happening proximally, which is that, right? So that is the actual shape of those roads on our retina. We make a copy of this guy and move it over there, and here you have sort of how we got this illusion to work. And I say we because my advisor and I created this illusion when I was doing my PhD, and we actually won an international contest, 3rd place with this illusion. So patting myself on the back, I guess. I don't know. But yeah, it was pretty cool. And the idea is that we're creating metamers here. Metamers are pictures that that are different but look the same. Okay? So you can get really cool illusions like this. This was done by my colleague Anna Cragen in grad school. These SUVs are actually all the same, right? You are using the cues in your visual world, right? You're using cues that you're really used to seeing, cues like occlusion, right? This car is in front of this one, just in front of this one. You know what that means in the 3-dimensional world. But when I take this car and I shift it back, and then I shift it back again, all these cars are the same size, right? This is um, it's all about the rule of constancy, right? So if all of these cars were the same size, three-dimensionally speaking, the ones that are closer are going to look bigger. Why? Because that's how things happen in our real world. So if I have three objects that are the same size in my real world, and I set one right in front of my face, and I set one 10 feet away from me, the one that's 10 feet away from me is going to be projecting a smaller image onto my retina than the one that is very close to me. Okay? All right, so again, using things like occlusion and constancy to make inferences about this picture that aren't necessarily the truth. So active organization also does things like it's how we sort of piece together these likely internal models of the world, right? So you saw with the cars, because of occlusion and constancy, it is most likely that these cars are different shapes. With the roads, it's most likely that this road is different from these two, because these two seem to be like they're converging into the distance, right? So they're probably the same shape. But we know that to not be true. Just wait for my animations to catch up with me here. Okay, so this kind of active organization allows us to perceive what we call gestalts. When it comes to perception, I ascribe to the Gestalt approach, and when we talk about gestalts, we talk about perceptual organization. The popular view is that the whole is greater than the sum of its parts. Okay, but in actuality, the whole is not greater than the sum of its parts. The whole is different from the sum of its parts. Okay, so when we talk about things like symmetry really pops out to us, right? These are Gestalt features. We actively organize things that are symmetrical. We actively organize things that are similar to one another. So you're most likely to group this into two circles, two squares, two circles, two squares. That's the pattern that you see. It's less likely that you see circle, square, square, circle, circle, square, square, circle, right? We group things according to proximity. So you're most likely to group these two and these two and these two. You're not more likely to group these two and these two, right? Because that's not how things typically group in the real world. We group according to things like closure. You're more likely to group these guys in a closed bracket than you are to group these guys in an open bracket, sort of C's backing up against each other, right? You're also more likely to, like continuity, right? It's called smoothness, but this is more like continuity, goodness of continuity. Okay, so you have this line. You're more likely to interpret this as a line like this and a line like this, two lines crossing over each other, than you are to interpret them like this. But when they're separated, you're not going to interpret, this is not good continuity here. You're not going to interpret this as one line, right? Okay, common fate. More likely to group the guys that are moving in the same direction than you are to group, let's say, like these two and these two and these two. We get illusions like the herring illusion. Okay, organization involves understanding relationships between parts. So when we get parts like this, you get this effect that these lines are maybe a little bit bent, they're a little bit curved, but they're not, right? So these two lines are perfectly straight. The Miller-Lyer, because of what we know about angles, and if you imagine that maybe this is like the corner of a floor, like a baseboard, sort of like this is the floor and this is the corner and this is the wall, and the wall's sort of like tilted up at you, or you could imagine it like you're looking up at a ceiling, and this is where the ceiling meets, like the ceiling joist, right? That's how we would interpret that in the real world, right? And what about this? This is sort of like a ledge, right? So imagine this is like the edge of a table or something, and this is the side of it, and this is the top of it, right? So this is the ledge. Now, because of the way that we interpret these two things, this line no longer looks the same length, even though it is the same length. These two lines are the same length. So I meant to do some drawing here so that you would believe me when I say these things. So hopefully I line these up properly. There we go. Okay, the lines are the same length. But because this relationship in 3 dimensions in the real world means something different to us than this relationship of lines in the real world, we don't interpret these lines as being the same length. Okay? We have things like the Ponzo illusion. Again, we're thinking about depth here, right? So this looks like it's receding into the distance, and if that's the case, then this line here is closer to us than this line here, but because they are the same size, this line obviously has to be bigger than. It's farther away from me and it looks the same size as this, so it's got to be a bigger line. So that's how I'm going to interpret it, even though these two lines are, once again, oh, well, let me try to be a little bit more convincing with that particular line drawing. So if we do something like this, right? Okay, those two lines are the same length. Okay. The whole is different from the sum of its parts. We saw this with the Dalmatian dog. You can see this with these illusions, right? When we just have two red lines, okay? When I just, can I do this? Yeah. Check that out. Okay? When I just have two red lines here, it's two red lines. No big deal, right? But when I add the black lines, now this has become something entirely different. This has become something that is maybe a 3-dimensional shape. Maybe these two lines are different size lines because of the 3-dimensional interpretation of this particular shape, right? Now there's something different. They're not greater, they're just different. These lines are exactly the same. They didn't change, right? And if I were to take away these lines and leave just the black lines, right? Okay, not necessarily so much depth there. Maybe there is a little bit of depth, but when I leave those black lines and add the red lines back, again, nothing changed about these stimuli, but the conglomeration of the stimuli made for a completely different percept. Whether or not that's greater or lesser is not the right terminology to use. It's just different. The dog, the picture of the Dalmatian dog, right? It just becomes different. It's not greater, it's not less than, because nothing in this picture changed. Nothing about the stimulus changed. Your percept changed. Okay? It became different. The relationship of the parts to one another became different. Okay? I don't know if you can see them in this picture. They're a little bit easier to see, but there are horses in this picture, right? So you can probably see the face of this little horse guy right here, right? It's the relationship of the parts to one another that help you to actively perceive, to perceptually organize, to actively organize your world. Okay? Okay. Now let's talk about, or in the next video, let's talk about bottom-up processing and top-down processing. I'll see you there.